Hello students. Now we will discuss about how to solve the Fourier transform. We will see some of the problems related to your exam also. Just for your exam, just see these problems. Okay. So first we will solve the Fourier transform for the delta function. Okay. Problem statement is find the Fourier transform of the following to sketch the magnitude and phase spectrum. Here you have to solve the Fourier transform and also you have to find out you have to draw the magnitude spectrum and phase spectrum. Okay. So the equation is how to convert the time domain signal to frequency domain. Derivation is not required. Okay, just memorize this equation. Okay, x of j omega is equal to integral of minus infinity to infinity x of t e to the power of minus j omega t dt. So this is the equation to determine the frequency domain signal from the time domain. This is the time domain signal. This one is the frequency domain signal, right? So by using Fourier transform, this is the mathematical representation of Fourier transform. Okay. So here we are converting time domain signal to frequency domain. Okay. By using a Fourier transform method. Okay. Here we have taken the input function is delta of t. You know very well this is a delta function, or we can also call that one as impulse function. Okay, the graphical representation of impulse function is this one, right? At t is equal to 0, the magnitude of impulse function is 1. Otherwise, it is 0, right? Yes. So now our we have to convert this delta function to, right? So sorry, time domain function to frequency domain, right? Just instead of this here x of t, you have to replace this delta of t. That's all. Okay. So x of j omega is the representation of frequency component. Okay. Integral at t is equal to 0, delta of t e to the power of minus j omega t dt. Because there is no time interval, right? So here at a particular instant of time, especially at t is equal to 0, the amplitude of the delta function is 1, right? That's why I have taken here t is equal to 0, right? At t is equal to 0, delta function becomes 1, amplitude becomes 1. Okay, e to the power of 0 means it is 1, right? So the frequency component, the frequency of delta, the frequency domain representation of delta function is 1. Okay, so for all the frequency component, what is this symbolic representation for all? This is reverse of a. Even you have seen these things in your maths, right? So if you are representing like this means for all value of omega is the frequency, right? So we are representing in the x-axis, the amplitude representing in the y-axis, right? For all value of frequency, right, the amplitude of delta function is 1 in the frequency domain, especially in the magnitude, right? The magnitude of the magnitude of the frequencies, magnitude of the given function, right? It is a frequency domain, right? How to determine that magnitude spectrum and phase spectrum? There is some equation is there. That one is very, very important. I have asked this question in your CAT exam, right? So magnitude spectrum we are determining, right? This one. So by using real part square, right, plus imaginary part square, x of j omega. Please write that one, x of real part of x of j omega, imaginary part of x of j omega, right? Square root of real part of real part of x of j omega square. Okay, again plus imaginary part of x of j omega with square. I mean, you know very well, a square plus b square. Okay, ma? This equation is used, we are using to determine the magnitude of the frequency spectrum or given function. Okay, so then how we are determining that angle? Minus tan inverse. For this one, minus tan inverse, right? B by a. B means imaginary part of function right? X of imaginary part of function and real part of function. So these two equations are very very important. Okay, this equation is used to determine magnitude of the function, and this equation is used to determine the phase angle of the function. Okay, we will see. Okay, so here we got only one magnitude as a one, so no need to calculate this square root of x square plus real part square plus imaginary part square. Okay, just for all value of frequency we will get the magnitude is 1, but here there is no phase angle, so the phase is 0. That's all. It is very very easy. Okay, we will see another problem. Okay, so x of t is equal to e to the power of minus 80 into u of t, right? Where u of t is the unit step function, right? You know how to represent that unit step function as a graphically, right? The x-axis shows the we are representing by t. T is a time we are representing in second. The y-axis is an amplitude, right? It is in here for unit step function. The magnitude is 1. So it is in functional representation is like this, right? For t is greater than equal to 0. This is 0, 1, 2, 3, 4, 5. Okay. T is greater than equal to 0. Then magnitude of the unit step function is 1. Otherwise 0. Otherwise means if t is less than 0, the magnitude of unit step function is 0. Right? So we are using this unit step function, right? This unit step function is multiplied with the exponential function, right? This is our input function, input of Fourier. We are converting that input function, this input function as a frequency domain. In frequency time domain is converted into frequency domain in the frequency function, right? So here, this is the equation, okay, Fourier transform equation. By using this equation, we are converting time domain signal to frequency domain, that is x of j omega, right? So just you have to substitute the x of t value, okay, e to the power of minus 80 u of t, right, e to the power of minus j omega t into dt. Just you have to add these two exponential component, right? And also you have to change this integral, because when u of t becomes 1, when t value is greater than equal to 0, which means the t value varies between 0 to infinity. So this time limits I have substituted in this integral, right? So the t values varies between 0 to infinity, right? So the magnitude is also, it becomes magnitude of unit step function also becomes 1, right? So here I have only two terms, exponential terms, right? E to the power of minus 80, e to the power of minus j omega t into dt, right? Just you have to add the power of these two terms, right? Then it becomes like this, okay? Then you have to integrate this function, right? You know very well how to integrate the exponential function, right? E to the power of minus t means e to the power of minus t divided by minus 1. It becomes here, like that minus will comes here, right? Similarly here also, here, so e to the power of integral of e to the power of minus of a plus j omega of into t. So if you are doing integration, so if you are applying integration for this function, right, for this equation, it becomes like this, okay? Same concept what I did here, right? E to the power of minus of a plus j omega into t divided by minus of a plus j omega, that's all. So you have to integrate with respect to the limits is 0 to infinity. So if you are applying it to minus infinity with respect to t means here you are substituting the infinity value for t, right? It becomes e to the power of minus infinity becomes 0, right? For e to the power of 0 means 1, right? So the denominator is plus 1, right? So e to the power of minus infinity becomes 0, minus, again minus of 1 plus a to the power of j omega, right? So here we have e to the power of minus a plus j omega into t, right? So I have substituted, instead of t I have substituted 0, right? E to the power of 0 means it becomes 1, right? 0 plus 1 divided by a plus j omega, right? So this is our frequency domain function, no? Right? We have converted our time domain to frequency domain. X of j omega is equal to 1 divided by a plus j omega, right? So now we have to find out the magnitude and phase angle for this function, right? So as I said before, so you have to use x of j omega means square, a square plus b square, right? A square plus b square, I mean this one is a real part, this one is imaginary part of this given function, right? This one is a, this one is a b, right? So square root of 1 divided by, right, a square, it becomes a square, it becomes omega square. What happens this j? So you know that j is j, the value of j is square root of minus 1. I will use different colors, okay? The value of j is square root of minus 1. If we are doing j square means just do square, it becomes minus 1. What happens? It becomes minus 1. So as it is in the function is within the modulus. So if it is there, if there is any minus, if there is any minus, it becomes plus, okay ba? So our function is the magnitude spectrum, right? So now the next step is we have to draw the magnitude spectrum, okay, and phase spectrum. So the function, by using this function, right, we are sketching the magnitude spectrum. Similarly, you have to calculate phase angle. So phase angle, how we are determining that phase angle? Theta is equal to tan inverse b by a. So here, um, so before doing that, okay, we have to do one small calculation, okay? So for that we have to multiply both numerator and denominator. This is our function, right? X of j omega function, 1 divided by a plus j omega. So for this one, for both numerator and denominator, this is numerator, this one is denominator, we have to multiply, we have to take complex conjugate of a plus j omega, right? Complex conjugate means if there is plus, we have to take as a minus. So a minus j omega, we have to multiply and divided by, we have to divide a minus j omega, okay? Then if we are simplifying this equation, it becomes like this, okay? Then we have to separate real and imaginary part. So it becomes a divided by a square plus omega square, this is a real part, minus j omega divided by a square plus omega square, this is the imaginary part. By using this, we are calculating tan inverse. Sorry, phase angle, right? Phase angle is equal to tan inverse, this one is the b, this one is the a, right? The numerator is b, so omega divided by a square plus omega square divided by, this one is a, so a divided by a square plus omega square, right? So the denominator of both the terms here, this one and this one, gets cancelled out, okay? Then the phase angle is, the final phase angle equation is tan inverse omega divided by a, okay? This is the sorry, this one is the magnitude, this one is the phase angle equation, right? So now we are sketching the macro spectrum and frequency spectrum, okay va? So for this one, we have to assume some value for the a, okay? So here just I have assumed the value of a as 2, okay? So first I am going to determine that magnitude spectrum for the positive value of omega, because in our magnitude spectrum, or if it is phase angle spectrum, we have both positive frequency and negative frequency. So first I am taking here the positive value of omega, okay? So then we have to find out the magnitude and phase angle, okay? So by using these two, we have already determined these two equations, the magnitude equations and phase angle equation, right? So by using these two, so we have to build the, right, or we have to find out the value of values, magnitude values and phase angle values, right? So with respect to the frequency, for different value of frequency, we have to find out magnitude of the Fourier, magnitude of the given function, right? Frequency domain function and phase angle of frequency domain function. Okay, so first just assume the value of a as a 2, and just instead of omega please substitute these values and determine the corresponding magnitude value and phase angle value. Okay, so that first substitute the omega value as a 0 in this equation, right? So then find out the magnitude for the magnitude of the function, right? Here the omega square is 0, then a is 2, it becomes square root of this one, a value is 2, right? It becomes 1 divided by 4, right? So then the square root of 4 is 2, it becomes 1 by 2, the 1 by 2 is zero point 0.5. Similarly you have to find out the magnitude and phase angle for the corresponding frequencies. So after determining all the values, right, again you have to find out for the negative, same procedure, right, in a for the negative value of frequency. Okay, after determining all those values, now you have to draw the graph. Okay, now we have to draw the graph. Okay, see here, this is positive value of omega, this one is negative value of omega, this one is the magnitude spectrum, this one is, see here, I have indicated the y-axis as a modulus of x of j omega. This one is the magnitude of the function. This one is the phase angle of the function. Okay, we will see how we are drawing, how we are sketching this frequency spectrum. These two function, these two graph, we call that one as frequency spectrum, right? So that frequency spectrum contains both magnitude spectrum and phase spectrum. Okay, so first we will draw the magnitude spectrum. Okay, the x-axis is a, we are taking x-axis value as a positive. First we are taking positive frequency, and the remaining, one second, one second. So our main thing is we have to sketch the magnitude spectrum and phase spectrum. This one is the phase spectrum. Okay, so this one is the magnitude spectrum. Okay, well, this one is phase spectrum. Phase, PHASE. Okay, phase spectrum. Okay, well, phase spectrum. Okay, so here, so we have to use this table to sketch the magnitude spectrum. Okay, these two tables, the first table is for positive frequency, the second table is for negative frequencies. Okay, so by using these two equations, right, these two equations we have determined the values of magnitude function, right, and also phase angle functions, right? So here we have assumed a is equal to 2, then frequency omega value, we have to use these values in order to determine phase angle and magnitude. Okay, so after determining the values of magnitude and phase angle, just we have to draw, right, that magnitude spectrum, right? So the in the magnitude spectrum, the x-axis consists of the values 0, 2, 4, 6, 8, 10, right? This is the positive frequency. So these values are negative frequencies. The y-axis are amplitude. Okay, the y-axis is a amplitude. Okay, so see here, just you have to use, you have to locate the values, that's all. So after that you have to see the table. See here, so for at omega is equal to 0, The magnitude is zero point 0.5. The phase angle is 0. First, we will draw the magnitude at 0, 0 0.5. Right? We will see. Just we have to put one point, right, at 0, right? The value, the maximum value is zero point 0.5, right? The next value is 0 0.5. For frequency 0 0.5, the magnitude is 0 0.48. Okay, at what is the value? I forget. The value is zero point 0.5, right? So omega is 0.5, 0 0.48, right? So omega 0.5, actually it will comes between here. This is 1 means the 0.5 will comes here. For 0.5, we have to take the 0.48. So similarly, the next omega value is 1. For 1, 0 0.447, right? So for 1, this is 1, 0 0.447. So you have to locate the points for both positive frequency and negative frequency. Then you have to join all the values. Then you will get magnitude spectrum. Similarly, phase spectrum also. So, right? So similarly, phase spectrum also using these two tables, right? This is positive frequency, this one is the negative frequency, right? This one is the negative frequency table. By using these two table, you have to draw magnitude spectrum and phase spectrum. That's all. Okay. Similarly, this is the third problem. Okay. First, you have to determine the Fourier series for the given function, right? So after this is the free Fourier, this is the Fourier transform function, right? X of j omega, right? Then afterwards you have to find out magnitude of x of j omega and phase angle of x of j omega, right? Using the equation, right? Real part square, right? Real part square plus imaginary part square. Okay. So imaginary part square usually this is square. Okay, this is, we call that one as a square plus b square. Okay, a square plus b square. Okay, square root of a square plus b square. Okay, so using this, using this function, you have to determine magnitude function and phase angle function, right? By using these two functions equations, you have to determine the magnitude spectrum and phase spectrum. You have to construct one table, right? So by assigning the values of omega 0, 1, 2, 3 up to infinity, right? So just substitute these values in this equation and find out the magnitude of the given function, right? Here the phase angle is 0. Here the phase angle is 0. So no need to find out that phase angle. Just you need to find out the magnitude spectrum, right? Afterwards, by using that table, you have to draw this graph. So based on the frequency, you have to locate the amplitudes. Okay. So then you have to join all the points. Then you will get magnitude spectrum. So I hope you will understand the Fourier transform and how to sketch the magnitude spectrum and phase spectrum for the given function. Thank you very much.